Happy Friday, y'all. Today we're going to be we're continuing with domain and range, but now we're going to go on to continuous data. So last time that we were together, we were going over discrete data. Now, just a reminder, discrete data usually looks like scatter plots, or it'll be points on a table. It can also be situations that are counted using whole numbers and cannot be divided into parts. So the example that we had here, the ice cream shop sells ice cream scoops for $3 and then charges an additional 20 cents for each topping. So in this case, we are counting each topping using whole numbers, and we can't say, oh, I'm going to get 1.5 toppings. No. You're either getting 1 topping or none, or 2 toppings. All right. We can't go anywhere in between whenever it comes to discrete data. So remember, discrete means disconnected. We have a whole bunch of points of data. They are not connected. There is a clear and distinct space between each point of data. Now, what we will be discussing today will be continuous data. So let's go ahead and talk about continuous data. Ooh, there we go. We don't have to write anything out. These situations can be measured. Remember last time we counted them. This time we will be measuring using rational numbers. That's fractions and decimals. Oh, I forgot to put numbers. And it can be divided into parts. So something that you may think about, we had the example with the carrots. So whenever we go over to H-E-B and we're going to buy, who really buys carrots? Let's buy apples. I love to buy apples. The thing is that you aren't buying the apples. Oh, okay, they're 50 cents each. No, instead they will say something like, oh, they're 50 cents per pound. And if so, then go buy them because that's super cheap. Do that. Usually apples are about, I don't know, like, $1.20 to about $2 a pound. So what'll happen is if you get 3 apples, it may not weigh 3 pounds. It might weigh 2.5 pounds. So these are the sort of situations that we can divide into parts, and we can use decimals or fractions to represent them. Let's continue. So because of that, before, like, let's say that was 1 pound and that was 2 pounds. Well, because I could have 1.5 pounds, what we're going to do this time is we're going to connect the 2 points of data with a line. So remember, connect, continuous means to be connected. That's why I wrote it in cursive. And here again, we have 2 points of data, and it is again connected with a line. So that means every single point in here, I'm counting every single bit of data. So that's all possible numbers between this point and that point. So if you take a look here, this is actually a quadratic function. This is an exponential function. And of course, don't forget our homeboy linear. So some characteristics. Remember, continuous means connected. That's why I have C-O-N-T bolded here so that you remember continuous, connected, cursive. There's no separation between any of the points of data. So you see here, there's a point of data here and here, and it's connected with a line. And we include fractions and decimals between the whole numbers on the line. Now, before, what we had used, our notation for discrete domain and range, we had the brace, we used commas, we listed everything in ascending order. This is called set notation. All right. If you have your braces and you're listing out the whole numbers, what you have there is called set notation. Now, what we'll be doing today would be using inequality notation. Now, if you think of inequality, you might think of those little alligator things. Oh God, don't get me started on the alligators. So we have symbols that look like this or that, and sometimes they kind of look like this. This is my favorite one for those of you who like anime. It reminds me of like the little angry faces. I just have to scoot a little bit closer. You know, that they get angry and they have the little blushy cheeks there too. If you know, you know. All right. Now, the thing is, don't feel ashamed, because even my seniors still have problems with this. Which of those inequality symbols is which? I don't know what the function I'm even talking about, miss. That's what happens a lot. So I want to help you guys out. You know, for all of those, including myself, whenever I was younger, I had difficulty trying to remember which symbol was which. When do I use it? I don't know. It's one of those less than, greater than, more than, I don't know. So let's start off with this one right here. Okay, so this symbol, I'm going to make it super simple for you. If you kind of rotate it a little, you know, like, I don't know, about 30 to 40 degrees to the left, it kind of looks like an L, doesn't it? It looks like less than. So if you have that little symbol and you're able to see an L with it, then you know that's the less than symbol, okay? In comparison, we have the opposite symbol. Now, sometimes you're like, oh, okay, well, whoever goes driving or someone's telling you, oh, turn left, and you take out your fingers and you're trying to figure out which one of these hands makes the L and the other one must be the right hand. No, this one, I love this one because this is actually the greater than symbol. Ooh, you like that? You like that, boo? Oh, heck yeah. So, less than makes the L. The greater than makes a giant G. Now, you also have these symbols here. Now, these people get confused as well, so I wanted to make sure that I confirmed exactly what they are. So this makes the L, so that's a less than or equal to. Sometimes people say less than or greater than. That's not a thing. Those are two different symbols, okay? So what this little line on the bottom means is it's also equal to. So I am including that value. And the opposite, that looks like the G here. So that's greater than or equal to. Okay, that's what that little line below means. All right. So now that we got that all figured out here, actually, I went over a little bit of what I wanted to just a while ago. So, whoop. There we go. Sometimes on your graphs, you'll see a solid dot. Will look like right there, or right there, or right there, right there. Yeah, we got solid dots. Now, whenever you have a solid dot, I know you guys have gone over this before, so this is kind of just a refresher. You guys have had number lines in the past, and you have either open or closed dots. Now, whenever it's closed, we're going to bring in a new term here, okay? The word I want you to use is inclusive. Now, this word is a big word. I could have used a smaller word, but you're smart little bunnies, and I know that you can use a big word in your repertoire. Why not? Now, the question is, what does inclusive mean? Function. Well, Well, let's take off the inclusive part, and it kind of sounds like include. Yeah, that's what that sounds like. It kind of sounds like include. So, that's exactly what it means. It means that if I have a solid circle on that value, I am including that value. Because I am including that value, that means I'm saying it's also equal to that value. So therefore, anytime we have a solid dot, we use these two bad boys. Now, for the most part, and I'll be going over this in just a little bit. Remember yesterday whenever I was telling you, we read a book from left to right, and a tree, you plant it into the ground and it grows up. As long as you're reading your domain from left to right and your range from bottom to top, you'll actually only have to use one of these symbols because it gets a little confusing. And I'll highlight that in just a bit. Let's move on to our other symbols. So either we have a solid dot or, We have an open circle. Now, if a solid dot means inclusive, then obviously an open dot should mean the opposite. Inclusive, so the opposite should be exclusive. And because it's the opposite, that probably means that if it's an open circle, I am not including that value. So therefore, my inclusive inequality symbols are these bad boys. There we go. So now that I have them on there, I want to use my highlighter. Because like I said, if you are reading from, and you know what, I'll even write it here. If you are reading your domain from, let me try that again. Oh well, from left to right, and you're reading your range, from bottom to top, that one didn't look too bad at all. Then in that case, the only two symbols that I would expect you to use are these two right here. And I'm going to show you an example of that right now. So let's continue. Let's close that off. Okay, I kind of just went over this right now. So reminder, domain, we will read the X values from left to right. Remember, domain, think of alphabetical order. D comes first, just like X comes first. Okay. We move from left to right. Oh man, that was actually really awesome. That was a good example. Left to right. Love it. Okay. But range, on the other hand, and you see how I try and keep, blue and pink opposites. Range, you read, where did that come from? That came from the bottom. So I know a lot of you guys like that song, or I don't know if it's old now. My kids used to love it. That bottoms up, your range is bottoms up. Yep. Start from the bottom and now we're here. All right. Just like I told you, think of a tree. You plant the seed and it grows up. Naturally, we are going to read a book from left to right, and naturally we grow up. Okay. So again, range, because we're going top to bottom, that's your y-axis. Those are your y values. All right. Woohoo! We finally get on to our first example. Look at that. So first thing we're going to look for is our domain. And this kind of looks like a quadratic function. Yeah, it looks like a little, kind of almost looks like a little frowny face or something. Here, look at that. Oh, I'm sad. Womp, womp, womp. Okay, so we have a parabolic function. It's facing down, and we have a couple of circles here. If you look really closely, I tried to zoom in here, and we can't get it zoomed in, but we have an open circle on this side and a closed circle over here. So let's go ahead and continue. Whoop. So since we're moving from left to right, let's see that one more time. I'm going to go ahead and bring over this line right over here because, let's see here, I'm going to use this as an example. So I'm moving this from left to right and I stop right here because this is where I begin. Now, as you'll notice, I have an open circle. Now, an open circle means to exclude. Okay, so because I have my open circle at -4, I've drawn a dashed line because I don't want to include that -4 symbol. Okay, so now I'm going to move all the way over. So I started at the left. And I want to find, because I have this line here, I'm going to keep following this line until I get to the very end. And I stop. Okay, so I start on the left side. I do not include the -4. And what I'm doing, I'm actually going to bring up my highlighter here. I'm going to, oh man. I was hoping it would be a lot prettier. Sorry about that. Whenever I'm counting these X values, I'm counting everything. Okay, so I don't want any white spots here. Everything from -4 to whatever that number is. I can't see right now. There we go. I'm including every single functioning number. All of these numbers between -4 and, let me see, that's going by 2s, so that must be 7. Okay, so remember, -4 is an open circle, so I'm not including it. But 7, that's a solid dot. I am including that. So you know what? Let me write out some of this. So I have -4 right here, and I have a 7 over there. You know what? Let me move that over a little. -4 and then 7 over there. Okay. Now, -4 I am not including. So I told you there were only 2 possible symbols you would use. I told you that if you had a solid dot, you would use this symbol. If you had an open dot, you would use this one. Now, because we read from left to right, and I said 4 is an open circle, I'm going to say -4 is less than, and then I'm going to put in there an X because these are my X values. But then over here, I have a solid dot. And I told you, as long as you read left to right, dang, bam. So the way we would read this would be -4 is, that makes an L, less than X, that makes another L, is less than or equal to 7. So altogether, -4 is less than X, less than or equal to 7. This means I am including all of the X values, that's why I colored it all in, between, but not including, -4 all the way to +7. That's what all this junk means. So let's write that out. -4, and then is less than, X is less than or equal to 7. Dang, that was awesome. Okay, so let's clear that off. And now that we did that, let's talk about range. We're no longer, I don't give a function about left to right anymore, okay? You know what? I really don't. I don't care about any of this anymore, okay? There is no left to right anymore. We are now doing bottoms up, okay? So, range, remember, start at the bottom, now we're here. So let's see that one more time. Now, what I'm going to be doing is I'm going to be moving. So you kind of saw that starting at the bottom. So I'm going to kind of slowly go on up until I find something, which I do right here. So now the thing is, if I look at this side, I have an open circle. So you'll notice I put a dashed line. But uh-oh, I have a closed circle over here. Now, remember, I was saying I was not including the 4, but I was including the 7. Now, remember how I told you I don't give a function about domain, no left or right. I only care about the Y value, so I don't care about all these numbers written here. I care about the Y value, and that Y value is 0. This one says I'm not including 0, but this one says I am. Well, guess what happens? Because one of these Y values is included, then that kind of trumps everything else, okay? So I am including the 0 value, and then I keep on chugging on up. Oh, and that's where I stop. There's nothing else above this hump. So, whoop. Now, what you'll notice here, I'm going to draw this out here, is at the very top, we have a curve. Whoop. That looks ugly. Whatever. Now, the thing is that this curve is actually made up. I don't know how many of you guys are like super into photography or video games or TVs, but especially TVs, you'll notice that they'll kind of advertise like, oh, this TV's got so many pixels more than the other. And, you know, why are pixels such a good thing? Well, the thing is, think of every single one of these dots, which it's going to equal, sorry, as a pixel. So whenever you're looking at your computer screen, man, it looks beautiful. Everything looks nice and crisp until you start zooming in, and then all of a sudden things kind of look blocky, right? And the reason it looks blocky is because you're seeing each and every one of those pixels. Now, what happens is that to create this nice smooth line, it's actually made up of a whole bunch of dots. And each one of these dots are so close to each other that it makes the appearance to be a solid line. So if you have a solid line up at the top, in actuality, what you have right up here is a solid circle. So because you have a solid circle up there, I would say that again, that solid circle or my solid line, that is going to be inclusive. And again, if I have an open circle somewhere, then that's exclusive. So let's get this figured out here. Starting at the bottom, actually, I wanted to continue writing. Sorry about that. I'll use my pink. Again, I only care about Y values. I don't care about X values. So here on the Y axis, that is a 0. Whoop. Okay. And it ranges all the way to a positive 4. So remember, we start at the bottom and then we move forward. Okay. So in that case, starting at 0, let's take a look. Okay, so we start at 0. Now this 0, as long as it has at least one of those as a solid dot, boo, that's inclusive. Now remember, range, I'm talking about my Y values. So, whoop. And now that 4 is a solid dot, so it's also inclusive. And I write it out. So that is 0 is less than or equal to Y, which is less than or equal to 4. That seems pretty easy. So seeing it all together, usually this is what I will have on my papers. You know, whenever we're back in the classroom, I like to have a blue highlighter and a pink highlighter or yellow, whichever one we have. I like to use pink. So I'll have my blue lines here. And notice how this one's a dashed line. That's showing that it's not including that -4, but it is including the 7. And then you have that solid line at the 0 in pink and that solid line at the 4. Love it. All right. So we're running low on time here, so I would like you to try one on your own. I chose one that was a little bit easier for you to try out, and I'm going to be giving you actually some more practice on Monday. I am also going to have tutoring today at 1 o'clock. So if you are kind of struggling and you want to do a couple more examples with me, I'd be more than happy to. So once again, remember, I'm looking for the domain and range. Now, you won't be able to write on this, so I'll actually do a little screenshot of just this portion here so that you can, or actually that will be on the slide. I know a lot of you guys were wanting to write on it, so you know what? I will go ahead and just give you your own copy of these notes, and you can make out little lines just like I did, or you can even just drag over the lines that I made. All right. Now remember, whenever it comes to domain, you are going to be moving from left, starting at the left, travel all the way to the end, to the right. And then with your range, that's bottoms up. So you're going to start at the bottom. Oop. That's where I start. I would draw my pink line, and then I keep following that line until I reach the very top, right there. And then those are the values you'll be using. I'm going to go ahead and discuss this problem at probably the beginning of Monday's notes, or we can discuss it during tutoring as well. But I'm going to go ahead and stop it here because I want to see what you guys can do on your own, and then we'll discuss this at a later time. All right? There we go. I went ahead and zoomed it up for you guys for this last minute here. If you want, you can put pause, take out your scratch paper, or well, you probably already have some out, or your dry erase board, and give this one a shot, okay? All right, I'll see y'all at tutoring and or Monday. Hasta luego.